Hey guys, today is Unit 2, Day 1 notes. So you guys have your entire trig packet here. So we're going to start out on the notes page on page 7. So this box that's highlighted in orange is going to be kind of our reference for the whole unit here. So I'm going to quickly talk through these because you guys already have them in your booklet, and we'll label a couple of pieces and then move on to some practice problems. So for trigonometry, we have sine, cosine, tangent, cosecant, secant, and cotangent. So all of these are talking about relationships with a triangle, a right triangle. So if we look at this triangle example over here, for this, we're using angle A. So just like in geometry, we're going to identify what our angle is, and so we're going to use angle A, and I'm going to put a little theta symbol in there so we can remember that that's the angle we're looking for. So it's important that you always check your directions. A lot of the times in this class we use angle A, but every once in a while we'll use a different angle. So make sure that you're labeling that. So we're going to put our theta in there. Now based off of the angle where the angle that we're using and where theta is, we're going to label the three sides of the triangle. So any side directly across from our 90-degree angle is always going to be our hypotenuse. So this side is directly across from our 90-degree angle, so that's going to be our hypotenuse. Then we're going to trace two lines from our theta right here. So the side that's directly across from our angle here, so the side that's directly across from angle A, that's called the opposite side. So right now we have our hypotenuse and we have our opposite, and the third side that's just next to but is not the hypotenuse, that's our adjacent side. So we're going to go through, label all of our triangles, and then we're going to use these ratios over here to fill in our answers. So you guys can take a look at the example problems right now if you'd like. Otherwise, we're going to just kind of dive into examples, and I'm going to leave this box at the top so you guys can see that. So right now we're looking at the first two problems. So right here it says find the 6 trigonometric ratios of angle A. So like I said, we're going to label that with our theta right away. So we're going to label all three sides, and then we're going to make sure we have a number for all three sides. So we're going to solve for our third side if that's missing. So the first thing I'm going to do is label my three sides. So I'm going to draw an arrow directly across from my theta. That's opposite. Then remember the one across from your 90-degree angle right here. That's your hypotenuse. And then right next to your theta that's not your hypotenuse is your adjacent. So we've labeled our three sides, and we're going to use that information from our highlighted box to answer those. But now we need to make sure we have a value for each of those three sides. So you can see here we have a 3, and on our hypotenuse we have a 5, but we're missing something for side B. So we're going to use the Pythagorean Theorem, and we're going to do a squared plus b squared equals c squared to solve for that third side. So we have our a squared, which is 3 squared. We are missing our b squared, and then our c squared, which is 5 squared. So we'll go ahead and solve for those. So that's 9 plus b squared equals 25. And then we'll take the square root of that b squared, and b equals 4. So that's our answer for our side of b. So I'm going to label that side as well on my triangle. So I have 3, 4, and 5 for my sides. So now I'm going to take that information and I'm going to use the box I have to do my ratios, and I'm just going to fill in my answers there. So sine of A is opposite over hypotenuse, so I have 3 over 5. Cosine is adjacent over hypotenuse, so we have 4 over 5. And tangent is opposite over adjacent, so 3 over 4. So there's our first three answers. Same thing for cosecant, and you'll notice these two are next to each other, so sine and cosecant, cosine and secant, and tangent and cotangent, because those are reciprocals. So all you have to do is take your original that you have next to it and flip it. So this becomes 5/3, 5 over 4, and then we have 4 over 3. So that's our solution for 1. Go ahead and try 2 on your own using your problem and your box with your explanations of your ratios, and then you can check your answers with me. I'm going to just fill them in as we go. So the first thing you guys want to do is solve for your missing side. So we have one side of 7. We're missing this side over here. And then we have our hypotenuse. So we're going to have, this is our a, and our a is missing. So we have a squared plus b squared, which is 7 squared, equals c squared, which is 64. So I have a squared plus 49 equals 64. So a squared equals 15. So we'll take the square root of that, and that's the square root of 15 then. So our side over here is the square root of 15. So I'm going to circle my 3 sides so I can see those, and go ahead and just put those into the ratios that you see, just like we did on problem 1. So you can pause the video and try those on your own, or you can just follow along with me as I fill those in. Okay, and you'll notice on these problems I have the cosecant of angle A and cotangent of angle A, and I have a radical in the bottom of our fraction there, and we cannot have a radical in the bottom. So what we're going to do is multiply that fraction for both of those by the radical that's in the bottom, both in the top and in the bottom. So now what that does is it gives us 8 root 15, and then radical 15 times radical 15 is just 15. So same thing down here, we're going to multiply that by radical 15 over radical 15, and these two become just 15, and then in our numerator we have 7 root 15. So that would be our final answer for those. So anytime you see a radical in the bottom, you have to go ahead and multiply by itself to eliminate that in the top and the bottom. So let's take a look at 3 and 4. It says to sketch a right triangle and label angle A and all sides, then find the values of the 5 trigonometric ratios that are not given. So we have cosine given, so it gives us the other 5 that we're going to find. So we'll sketch our triangle. Remember, it has to be a right triangle. So I'm going to say it's an A, B, C triangle. So it says cosine of A, so I'm going to label my theta down in A, and then I'm going to label my 3 sides. So remember, across from my 90 degree is my hypotenuse. Directly across from my theta is my opposite, and next to, that's not my hypotenuse, is my adjacent. So I labeled my 3 sides, and again, feel free to reference the box back here on the first page, but it's asking us for the sine of angle A, so it's opposite over hypotenuse. So we're going to fill that in, opposite over hypotenuse based off of our numbers. So let's label our sides here. We have cosine, oh actually that was sine, let's look at cosine. Adjacent over hypotenuse, so we have our adjacent here, so that would be 1, and our hypotenuse, which is right here, so 2. So we need to solve for our third side, so we're going to do 1 squared plus b squared equals c squared. So that's 1 plus b squared equals 4. So we'll subtract our 1, and we have b squared equals 3. So we'll take the square root of that, and our missing side is root 3. So now we're going to go ahead and fill in the blanks for all of those. So we're looking for the sine of angle A. So we're going to have root 3 over 2. Tangent, which is opposite over adjacent, so we're going to have root 3 over 1. Cosecant, so we're looking for the reciprocal, and if you can't remember, go ahead and flip back. Cosecant is the reciprocal of our sine, so sine is right here, so it's going to be 2 over root 3. Now remember what I said, you cannot have a radical in the bottom, so we're going to multiply both of these by root 3, and then we'll have 2 root 3 over 3 there. Our secant is 2 over 1. You can leave it like that, or you can just put 2. And our cotangent is 1 over root 3. Same thing again. We're going to multiply by root 3 and get 1 root 3. You don't have to keep that 1 there over 3. So that's it for 3. Same thing for 4. So if you're comfortable, go ahead and pause it, and you can try to do 4 on your own. If not, go ahead and follow along with me. We're doing the same thing again. So we're going to draw out our triangle, label our right angle. I'm going to do an ABC triangle again. So I'm going to label my theta. That's going to be the first thing I do. And now it's telling me it's the cosecant. So feel free to flip back. Cosecant is the reciprocal of sine. So we are looking for hypotenuse over opposite that's given to us. So we have our hypotenuse over opposite. So let's label our sides, and then we'll fill in our numbers. So remember, across from the 90, that's our hypotenuse. So that's going to be 5. Then straight across from our angle A is our opposite. So that'll be 4. And then this is going to be our adjacent. We have to solve for that one. Now, if you guys remember a 3, 4, 5 triangle, you can just automatically assume that that side that's missing is a 3, 4, 5 triangle. Remembering that the 5 always has to be opposite of the 90-degree angle or the hypotenuse. If you don't know that off the top of your head, go ahead and plug it in to the Pythagorean Theorem of a squared plus b squared equals c squared. But I'm going to say that's a 3 right there. I know that's true. And then we're just going to go through and label our 5 missing ratios here. So we have the sine. So remember, if you have your cheat sheet, sine is opposite over hypotenuse. So we have 4 over 5. Then we have cosine, 3 over 5. Tangent, 4 over 3. Secant, again, you can look back, is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. So 3 over 4. So last problem on this sheet says, sketch a right triangle and label all sides. Then find the trig ratios with the given information. Given the tangent of angle B equals 3 over 5, find the sine of B. So we're going to draw a right triangle again. I'm going to put my 90-degree angle in here, and I'm going to label it an A, B, C triangle. Notice this time we're doing angle B. So I'm going to put my theta in for B, and I'm going to label my 3 sides. My hypotenuse, my opposite, and my adjacent. So it's giving me a tangent. So for my SOHCAHTOA that we'll talk about too, tangent is opposite over adjacent. So I have a 3 and a 5. Now this triangle has a 3 and a 5, but it's not a 3, 4, 5 triangle. Remember I said on 4, the biggest side has to be a 5, which is a hypotenuse. So we are going to go ahead and do a squared plus b squared equals c squared to find our missing side here. So we have a squared plus b squared equals c squared. So that gives us 9 plus 25 equals c squared. So that is 34. So we'll take the square root of that, and we'll just leave that as 34. Square root of 34. So those are our 3 sides. So it's given the tangent of B, so now they're asking us to find the sine. So the sine is opposite, so opposite is our 3, and hypotenuse. So hypotenuse is our radical 34. Now again, remember, radical 34 cannot be in the denominator, so we're going to multiply the top and the bottom to eliminate that radical, and we now have 3 root 34 over 34. And that's your final answer.